Sri Vaishnav, and I don't know, I just thought why not make videos of me solving the daily challenge every day. That would make me both consistent and I don't know, it won't be lonely. So today's Leetcode Daily challenge question is LC 523 continuous subarray sum, and this seems to be a medium problem, and it seems I've already solved it. Apart from that, let's once go through the question. It says we're given an integer array nums and then an integer k, and we need to find a continuous subarray of size at least 2 whose elements sum up to a multiple of k, and they're asking us if it is possible or not, and 0 is always a multiple of k. Okay, let's go through the test cases. They tell us more than the description. So here we have this array 23, 2, 4, 6, 7, and we need to find a continuous subarray whose sum is a multiple of k, which is 6 in this case. Here we have this subarray 2, 4, but I think we could have also chosen 2, 4, 6, because then it would be 12. The sum would be 12, which is 2 times 6. But we don't have to give any other information about that. We just need to say if it is possible to create or not. And so even if we find one possible subarray, we can just return true. And yeah, the constraints are the length of the array can be 10 power 5, so the brute force might not work. And yeah, acceptance 28. I think it's a little tricky. So once a great man said that premature optimization is the root of all evil. So let's not just jump right into the solution and just try to optimize it from the brute force. So what would be the brute force? The brute force would be to check for every subarray, find its sum, and then see if it is a multiple of k, and if we find at least one instance, then we can just return true. So the time complexity of this would be n square, because checking for each subarray would be n square, and then we can calculate the sum. We can calculate the running sum, or we could use a prefix sum in that case. So in so the time complexity would be n square, which would be too slow for this constraint of 10 power 5. So how do we do? I'm acting like thinking, but I've solved some problems like this before, so I'm getting some hints from my past self. I could use prefix sum along with hash map, but how do I approach that? So generally, I hope you all know about prefix sum. If not, I would just recommend you to once go and check about prefix sum. I would add some links in the description. So prefix sum is given an array, we create a prefix sum of that array such that we have a running sum up till that. So for a, b, c, prefix sum would be a, b, a plus b. Just consider that is sum a, b, c. So if I want the sum of just b, c, what I could do is I could take the prefix sum of c, which would be a, b, c, so all the numbers up till then, and then I could remove the numbers which are not required. So here a is not required, so I can remove a, so that would be a, b, c minus a, which would be b, c. So you can using prefix sum, you can find sum of any subarray in O of one time, and the time for construction would be a linear loop, so which would be O of n. But how would we leverage this? So actually, one good thing about this problem is, as they are saying, the sum should be a multiple of k. No, if something is a multiple of k only when it's when the remainder when divided by k is 0. So if you have any number like n times k, in that case, if we divide this by k, the remainder, the quotient would be n, but the remainder would be 0. So right, so if any number in this whole universe can be divided into uh, divided into k element, k different categories, with remainder 0, 1, 2, so on up to k minus 1. So yeah, so if we create so our problem would be simply is to find a subarray in this array whose sums remainder when divided by k is 0. Okay, and as I said, if you have gone through prefix sum, so this is the sum of a subarray from the range I to j would be prefix sum of j minus prefix sum of I. Here okay, so first we need to decide so if I is included or not. So if I want to find prefix sums all from I to j, in that case I would need the prefix sum of j minus the prefix sum of I minus 1, because everything till I minus 1 we got to delete, we got to subtract, so this would be prefix sum of j, and then if we subtract prefix sum of I minus 1, all that we are left is the sum between the sum of the subarray I to j, right? And we need this to be 0, right? So that means the value of prefix of j, the value of prefix of I minus 1, they have to be equal, right? So let's get along with these lines. And I forgot to mention, I nowadays I don't write Leetcode programs on Leetcode website because I've got a cool extension on PyCharm. It's an extension, even you can install it. I'll put the link of the extension in the description. So simply you can select a problem here, and then you'd get the problem description on the left side, and you can write your code on the right side. And the great part is you can submit your codes from here, and you don't have to have a premium subscription to get autocorrect here, because autocorrect already works here, you see. So yeah, it's a win-win situation. So for the rest of the video, I'll keep coding in PyCharm here. Yeah, so the function definition here is check subarray sum, and we are given nums, and we are given an integer k. And so let's going on the lines that we have discussed before. Let me start write code. So first we need to have we need to check. So if we have a prefix sum of, let's say, x, so we need to check if I've already got x in the past, so that I can create a subarray from that point till this point, which would get a remainder of 0, because x minus x would be 0. And yeah, so for that I need to store the last point when the prefix sum was equal, and for that I would need a hash map, because it's generally we could have been okay with a set, but they said that there should be at least 2 elements, so we also need to know the index of the last time when the prefix sum was x. So that's why we're using a hash map. Oh, clear. So prefixes, let this be a dictionary, it's like a hash map in Python. And then let me have a variable of prefix, and for iterating through the array, I'm just going to enumerate, because it gives us both index and value at the same time. I don't have to again write the code to get the value from the index. So yeah, first let me add prefix. Let me add the current value to the prefix. And then take the reminder. So now I got to check if this prefix is already there in prefixes. If it is, I got to be sure that its index, the current index minus the the last time we had the same prefix is at least 2. In that case, yeah, so we have already got a prefix. Now let's say the current prefix is the prefix reminder is x, and then we already got an x before, so I could choose the subarray sum between these two elements, right? And then the subarray prefix sum reminder would be x minus x, which would be 0, which means that this sum is a factor of k, right? So in this case I got to return true, and else if not, if it's not, so we got to store the current prefix for our future cells, right? So prefixes of current prefix is equals to end. And no, we need to do this change if and only if the prefix is already not it's not already present in prefixes. Because let's say we have a test case something like this 5, 0, 0, 0. In this case, using this subarray, this would actually be a valid subarray because its sum is 0, and no matter what number k is, k be 101, no matter what number it is, 0 is a factor of 101 because 101, 0 divided by 101 yields a remainder of 0. Because I'm not sure of that, but here they said that 0 is always a multiple of k. Yeah, because k times 0 is 0, right? So in this case, if we keep on updating the prefix, so when I come, so first I'll update that this prefix 0 was here, and then I update the prefix 0 was here, and then I update the prefix 0 was here. So actually we need to find the distance between the two numbers, the difference between the 2 points has to be at least 2. So if we keep on updating, then maybe this, instead of choosing this, we might be choosing this, and instead of this we might be choosing this, in which case it might not give us at least 2 integers. So you get the point. We don't need to find the smallest subarray, we just need to find any subarray. So to be on the safe side, I want to choose the subarrays which are as long as possible, so that I don't run into this constraint of at least 2 elements. Hope I'm clear. No, I'm not that clear, but I think you would get it, right? That's the reason I'm updating this only in the else statement. And then if you have not found any such instance, you need to return true. Yeah, looks good to me. Let's do some code refactoring. Everything is good, but something seems off. What if okay, all right, looks good to me. Let's run this. Yeah, it works on 6. Okay, let me just copy. While submitting code, it would be more intuitive if I do this on the web page, right? Yeah, so let me run. I think it looks good, but I don't know, I'm a little I don't know, suspicious. Yeah, we got this test case which is wrong. Okay. Let us check. So this is the subarray, this is the array, and the case 13, our output is true, but it should actually be false. Oh, my mistake. If you haven't found any instance, that case we got to return false, right? Oh, you should have pointed me out. Why were you silent? Aren't you paying attention? Huh. Okay, it seems good. Or what if look, what if, wait, I got this test case. What if the array is just 0 0, and let's k be anything, let's say let it be 4? I think our code would not work in this case. Yeah, so the reason our code would not work in this case is because even though we have two numbers, we are not choosing the both, because the first time we are registering 0 and the second time we are registering 0, so the prefix of this 0 is excluding this number. So when I do this minus this, it would give me 0, but the index would be the length would be only 1. So actually there is a 0, there is a 0 even before the array. Do you understand me? So when I say prefix of a minus prefix of b, here I'm excluding a from my sum, so it would be from a plus 1, right? So here, here the array is 0, 0. So first when I come to this 0, I make prefix, and then this indices be 1. So I make the prefix of 0 as 1. Here when I say prefix of 0, I'm not including this 0, I'm just excluding this. And when I come to prefix of 1, prefix of 0, this case it would be, the index would be 0, the index would be 1 here. And even though it's a valid prefix of 0, 0 minus 0 is still 0, but here we're not including 0, so 1 minus 0 is just 1, so there is just one number we're considering. Actually we got to consider both the numbers, and 0 means nothing, so there is nothing even before we started the array, right? So let's add that. So there might be prefix 0 and its index would be minus 1. I mean, it's before the starting of the array. Now it should work. I mean, it's a little tricky. You got to think a bit more, but you got to think, you got to ruminate. Is that not sure. Yeah, you got to ruminate on this a little more before it gets intuitive. It's easy for me to say, because I've already solved such problems before. Yeah, it works. So I've already solved such problems before, and I remember the problems. They were like subarray sum equal to k or something like that. Yeah, subarray sums equals k. So this is the problem which had a similar, yeah, so this problem has a similar logic. You're given an array and an integer k. You need to find the total number of subarrays whose sum is equals to k. And even I think in this uses a similar logic. So I'd add the link of this problem in the description as well, so that you can solve this after solving this problem. And that's it from my side. If you like my video, please hit a like, comment on the video, and share it with your friends. And I'll keep posting videos consistently, so you can just follow me. Bye bye.